Welcome to The Explainer. Today, we're diving into what I like to call a massive mystery, right at the cutting edge of artificial intelligence. Right now, large language models have these absolutely incredible reasoning capabilities, but their memory? Well, it has a critical, fundamental limitation. Think of it as a missing link in how machines actually perceive human knowledge. So we're going to explore a really exciting breakthrough framework called RAG Anything, which fundamentally reimagines how AI reads, remembers, and retrieves information.
So let's just jump right in. I want you to imagine hiring a brilliant, lightning-fast researcher. Sounds great, right? But there's a catch. They're wearing a very specific kind of blindfold. They can literally only read plain text. If you hand them a complex document, they'll strip away all the charts, completely ignore the data tables, and just bypass the mathematical equations altogether. What happens when your AI does exactly that? Well, it misses the point entirely. And that is the massive information loss happening in current Retrieval-Augmented Generation or RAG systems today.
Here's the thing. Current RAG systems are basically living on a strict text-only diet. When they ingest a document, they completely flatten complex formats into weak, inadequate textual summaries, or they just toss the visual data in the trash. But as we all know, that is not how the real world works. Authentic human knowledge is messy, and it's inherently multimodal. Real-world documents are these rich combinations of text, visual elements, structured tables, and complex math. If an AI can't see the whole picture, it definitely can't give you the whole truth.
All right, here's our roadmap for today. First, the multimodal reality. 2, introducing RAG Anything. 3, the dual graph solution. 4, cross-modal hybrid retrieval. And finally, Section 5, beating the benchmarks.
Okay, let's kick things off with part 1, the multimodal reality, and why we desperately need to move beyond text-only AI.
Just think about the standard PowerPoint decks or Excel spreadsheets you probably use every single day. Critical insights in the professional world are locked inside pie charts, bar graphs, and specific visual layouts. Standard text RAG simply throws all this visual semantics away. It literally cannot capture the spatial layout or the hierarchical relationships that give those documents their actual meaning.
To really grasp how catastrophic this knowledge gap is, let's look at 3 specific scenarios from the source material. In scientific research, core discoveries are communicated through plots and statistical visualizations, which are totally invisible to a text-only AI. In financial analysis, investment insights are encoded in visual patterns, market charts and correlation matrices, not just long paragraphs of text. And in medical literature, life-critical information is literally trapped inside radiological images and clinical data tables. A text-only AI missing a key detail in a medical chart? That's not just an inconvenience. It makes the system entirely inadequate for real-world use.
Which brings us to part 2, introducing RAG Anything. This is the unified framework that changes the game.
So, how exactly does RAG Anything fix this? It all comes down to how it parses documents. Instead of forcing all these diverse modalities into a rigid text-centric pipeline, it uses this incredible process called universal representation. It decomposes raw multimodal inputs, whether that's a PDF, an image, a complex table, into atomic knowledge units. Think of them like individual Lego blocks. But here's the absolute magic trick. It preserves their structural context and semantic alignment while it does it. It doesn't just read the text, it understands exactly how everything fits together. By treating all these inputs as interconnected atomic entities, RAG Anything transforms messy, heterogeneous files into a beautifully coherent substrate for retrieval. Think about how you read a textbook. When you look at an equation, your brain naturally links it to the definition in the paragraph right above it, right? When you look at a figure, you ground it to the caption below it. Well, RAG Anything's specialized parsers do exactly this. Mathematical expressions are converted to symbolic representations, tables are parsed into highly structured cells, and figures are explicitly linked to their captions. Absolutely nothing gets lost in translation.
All right, moving on to part 3. Let's look at the actual architecture with the dual graph solution and see how it maps memory.
Now you might be thinking, why not just build one giant graph for everything? Well, actually, if you do that, you risk losing the unique structural signals of all those different modalities. So RAG Anything builds 2 complementary graphs instead. First up, we have the text-based knowledge graph. This operates a lot like the established text-centric pipelines you might already know. It uses named entity recognition and relation extraction to carefully map out all the explicit, fine-grained semantic connections found purely in the plain text of the document.
But here is where it gets really cool. Now we introduce the second graph, the cross-modal knowledge graph. This is where non-text units, like images and tables, are transformed into structured graph entities. The system uses vision language models to ground these non-text elements, generating detailed descriptions and summaries for them based on their surrounding context. So a chart isn't just an isolated, dumb image anymore. It becomes a structural anchor point, explicitly connected to the text around it through direct belongs-to relationships.
And here is the whole shebang, the master architecture bringing it all together. RAG Anything takes the text space graph and the cross-modal graph and literally fuses them through a process called entity alignment. If an entity is mentioned in a paragraph and that same entity also appears in a chart, the system elegantly merges them. This creates one unified, completely holistic view of the document. Plus, it creates a dense vector representation, essentially a mathematical fingerprint for every single component, whether it's text, an image chunk, or a relationship. It's building a perfect, multidimensional map of knowledge.
Let's shift gears to part 4, cross-modal hybrid retrieval. Basically, how does this thing actually search?
So what happens when you ask it a question? The system launches a highly coordinated, two-pronged attack. Step 1 is structural knowledge navigation. It uses those explicitly mapped relationships in our dual graph to follow multi-hop reasoning paths. If you ask about a concept that connects a text paragraph to a data table, it follows the literal graph edges to find it. Step 2 runs simultaneously. Semantic similarity matching. This searches the dense vector space we just talked about to find implicit connections, content that's semantically relevant to your question, even if it isn't directly explicitly linked in the structural graph.
Now, both of these search pathways are going to return a pool of candidates. But you can't just dump all of that into a language model and hope for the best. RAG Anything unifies this candidate pool using what they call multi-signal fusion scoring. This brilliantly balances the structural importance from the graph topology with the semantic similarity from the vector search. It even analyzes your original query for specific lexical cues, like if you explicitly asked for a chart or a table, and weights the modalities accordingly to find the absolutely perfect answer for you.
Okay, finally, part 5, beating the benchmarks. Time to look at the real-world performance.
So, does this actually work better? The data says yes, absolutely. Just look at these numbers from the long bench dataset, which rigorously tests long context multimodal document comprehension. RAG Anything hits a 46.6% overall accuracy. That represents a massive performance leap over state-of-the-art baselines like LightRAG and the native GPT-4o mini model. Across academic papers, financial reports, administrative files, RAG Anything dominates. The researchers even noted that these performance gains become particularly pronounced on very long documents where the relevant evidence is scattered across multiple modalities and sections, which is exactly where traditional approaches completely fall apart.
So what's the big takeaway from all this? Basically, RAG Anything officially solves the blindfolded AI problem. By decomposing documents into atomic units, it flawlessly preserves the vital context between text, charts, and equations. It completely eliminates architectural fragmentation by merging text and cross-modal knowledge graphs into one beautifully unified representation. And by combining explicit graph navigation with semantic vector search, it delivers a level of accuracy that simply dominates complex long-context benchmarks. It's a real game-changer.
We are literally no longer forcing AI to read our world through a tiny text-only keyhole. We are finally opening the door to true, comprehensive machine intelligence. And that leaves us with a truly fascinating question to ponder. With AI finally able to seamlessly map and understand our most complex, multimodal data, from life-saving medical charts to hidden financial matrices, what previously unsolvable problems will we conquer next? Thank you so much for joining me on this explainer. Keep learning, and I'll catch you next time.